So today's video, I'm going to explain about the transformer on no load. Here there are two sides, as you already know. This is the pictorial representation of the transformer. Here it is the primary section and it is the secondary side. Here in the primary winding we are going to give the power supply, that is V1, and here the secondary side is kept open, and here we are naming it as a V2 voltage. When the power supply is given, that is the we in previous video we have discussed that we have to give the power supply in AC only. When the AC power supply is given to the primary side of the transformer, and the secondary side is kept open, there is no load is connected here, this is no load. And when the voltage is applied at the primary side, the flow of I naught through the primary windings is taken place, and which causes the alternating flux in the core of the transformer, that is called as the main flux. And here I naught is playing the main important role here. It is also called as a excitation current or exciting current. It has two components, one is Im and another one is IE. Im is nothing but what? It is the magnetizing component, and IE is, as the name indicates itself, E is nothing but the energy component, M is nothing but what? Magnetizing component. Why these two are important here? Because Im is the magnetizing component which is used to create the flux. It is the main component which is used for creating the flux inside the core of the transformer. And what about the IE? IE is nothing but it is the energy component which is used to overcome the hysteresis and eddy current losses in the core. So there are two losses and are there here. One is hysteresis loss and eddy current loss, which are induced in the core of the transformer. So to overcome these losses, we have to use the IE, that is energy component, and it also reduces some amount of copper losses in the primary side of the transformer. And we are going to explain it by using the phasor diagram here. So let us look at the phasor diagram. It is the main flux. So starting from this point, this is the O, I can say, basic point. And so if you consider the working of the transformer, whenever the AC supply is given to the primary side, it will induces the current I naught, and the flux will produces. This flux produces the EMF in the primary winding, and which links the when the flux links with the secondary winding, E2 will be produced. Okay, so induced EMFs E1 and E2 are indicating the induced EMFs here. E1 is the EMF at the primary side, and even E2 is the EMF induced at the secondary side. Induced EMFs, as per the phasor diagram here, induced EMF E1 and E2 are always in phase with each other. So E1 is also is in phase with E2 and lags behind the main flux phi 2. This is the flux, and these are EMFs E1 and E2. If you consider the angle between these EMFs, induced EMFs, and the main flux, the pi by 2 angle is the difference, and E1 and E2 always lag behind the main flux. And then the applied voltage V1, okay, the applied voltage V1 leads the flux by an angle phi by 2, and which is opposite to E1. So here we have to consider here the applied voltage V1 is leads the flux by an angle phi by 2. It leads the angle phi by 2, but it is in opposition with the induced EMF V1 E1. So V1 is equal to minus of E1. Okay, here V1 is the supply voltage, and through this V1 the I0 is produced. I0 produces the flux, and this flux when links with the primary winding, it produces the EMF in the primary winding. But this EMF which is produced by the power supply V1, it is always in opposition with each other, and they are in phase. And V2 and E2 are in phase with each other, equal and no voltage drop at the secondary side. Since there is no load is connected at the secondary side, V1 and V2 are in phase with each other and there is no voltage drop. The voltage is remains constant or same. And the here the main components, which is the IM, this is the I naught, which is uh, which is the exciting current, which has two components, Im and Ie. Im will be indicating by the equation Im is equal to I naught sine phi, and it is in phase with the phi. This is in phase with the phi, and which will be lags V1 by an angle phi by 2. See here, this is the angle V, this is the V1 here, which will be lags behind the V1 by pi by 2. And IE is nothing but what here, I naught cos phi naught. It is in phase with, it is in phase with V1. And what about the power produced here at a no load? So input power at no load will be V1 into IE. V1 into IE. Why IE? Because it is the main component which is produce the energy. So that V1 is equal to IE. IE is nothing but what? From the phasor diagram I can see here I naught cos phi naught. So phi naught will be is equal to the main flux. Okay, flux at the no load, that is equal to tan inverse of Im by IE. This is the equation of phi, and the input power is equal to V1 I naught cos phi naught. So this is all about the transformer on no load, and in next video I am going to explain the transformer on load. Thanks for watching.